Hello friends, a podcast to introduce section 6.2 in the Algebra 2 book. As promised, now that we've introduced fractional exponents and this new radical notation, what we're going to do is go through the same exponent rules that we've done a couple of times now. We're just going to do them with the fractional exponents. So some things that should be familiar to you are simplest radical form, in other words, reducing a term to its simplest form, and like radicals. And this is just like terms. Same variable to the same exponent, same variable or same radical to the same radical index and radicand. So that's the number inside the radical and the number outside the root. So here they are again in all their glory, all the properties of rational exponents. And notice there's absolutely no difference on this property side. The rules are exactly the same. What is different is what you see on the example side. Notice we're working some fractions now. So for all you people that are a little rusty on, all your rules, your operations with fractions, this is a good opportunity to brush up on those and make sure they're good. I also mentioned last class that I wasn't going to be doing any more of the specific homework problems, but I would do problems that were very similar to the homework problems and leave it to you to figure out the actual homework. So I want to point out these examples I'm going through are exactly the same as what you're going to see on your homework paper. I attached the practice sheet to the email you got. And just to make my point, here's the first set of problems. On the homework, simplify the expression using the properties of radicals and rational exponents. Example 1, use properties of rational exponents to simplify the expression. Same thing. So this just takes you straight forward using the rule. So if I'm multiplying the same base, I add the exponent. So you got to be able to add 1/2 plus 3/4. Again, your calculator will do it for you. Let me remind you, if I have right here 1/2 plus 3/4, I can do, and actually because of order of operations, I don't even need to put them in parentheses, 1/2 plus 3/4, and hit enter. I'm going to get a decimal, but if I hit math, enter, enter, it converts this decimal into a fraction. So using your calculator, you should be able to do all these, but don't rest on your laurels thinking that, oh, I can do all these number ones with my calculator, so I don't have to know anything. The next step is to do these with variables. So you have to know the rules, and you have to be able to do the fractions and know when to use what. So these rules should look very familiar when we did the square root section earlier in the year. The only difference was this was just a radical and an assumed 2. Now it can be any number as the radicand, as the index. And if I have a radicand, I can break that into two numbers. So if a plus a times b equals whatever's under here, I can break it up. And we'll take some practice. So here's an example of where I'd want to do this. 27 doesn't have an even fifth root. 9 doesn't have an even fifth root. But 27 times 9 is 243, and the 243 does have a fifth root, which is 3. So these are the reasons you'd want to manipulate, and you can see example B. So I want you to try these two right here. Pause, grab a piece of paper, and try to work your magic. We'll go and go over them in class tomorrow. Examples 3 and 4 use the same rule in a different way. So 128 does not have a fifth root. But if I break that into 32 times 4, then I can take the fifth root of 32, which is 2, and just leave the fifth root of 4. So this is now simplified radical form. Let me show you again how to get all the perfect fifths, all the perfect anythings on your calculator. So if I'm not sure what all the fifth roots are, I can go to y equals, hit x to the fifth. Notice the keystrokes are right here. And when I hit second table, I now have a list of all the perfect fifths. I'll shoot down here to 0. And I can see, fifth root of 1 is 1, fifth root of 32 is 2, fifth root of 243 is 3, and so on. And I could do that for any power just by going to the y equals button and changing this exponent right here. So here's two more practice. Do these on a piece of paper in your notebook, and we will go over them in class tomorrow. In example 5, we actually get into the variables, and we will be practicing this in class, but it's worth taking a look at example 5 and example 6, again, just using the exponent rules. Here's one more example and two more to try. All right, we'll practice tomorrow. Have a good night.